Hello, my name is Arman Gupta, and today, over the course of the next couple minutes, I'll be taking you through the manufacturing process of creating a ring on the lathe. I'll start by creating a drawing that has all the critical dimensions, so that each geometry is fully constrained. From there, I'll create a 3D model from that drawing, and then I'll cover all the layout tools and manufacturing tools required to make it, and also some alternatives for some of them. One critical tool that you will need is a lathe, and the corresponding tools that it uses. Once you know all the tools, I'll move on to the step-by-step instructions that'll allow you to complete the project. I'll also be showing some of these steps with computer-aided design simulation and animation software. Let's begin with the digital sketch and 3D model. As you can see here, I have created a sketch in Autodesk Fusion 360, which is a powerful, collaborative, cloud-based CAD software. The dimensions of the ring are fairly straightforward. The inner circle has a diameter equal to my finger width, and the outside circle is just the inside one plus 2 mm, to give the ring a thickness of 2 mm. Here's a representation with several orthographic and isometric views. It largely conveys the same information, however, machinists usually prefer this format since it's easy to see certain dimensions. Also, certain dimensions are unique to this format, such as the length of the ring, which is not possible to show in a single 2D orthographic view. Finally, the details of that 2D sketch we can extrude, chamfer, countersink, and apply a knurling pattern to get our 3D model. On the 3D model, we can see that it has an 18mm through hole with a chamfer on it. Additionally, we can see a nice looking knurling pattern along the entire body of the ring. Now that we have a solid understanding of what to build, let's get into the tools that are going to be required to build it. The first thing you're going to want is some Engineer's Blue. Engineer's Blue is great because it allows you to more clearly see any marks you make on the metal, while covering up pre-existing scratches and scuffs. If you do not have Engineer's Blue, you can instead use a Sharpie. However, something to be noted is that the Sharpie marks are likely to fade away upon being exerted to a heat which almost all machining tasks produce. To check your dimensions when the ring is finished, you'll want to use a caliper or a micrometer. The next thing you'll want is a small deburring tool. If you don't have one, you might be able to use a small, thin file. Since the cuts made by the lathe will be really rough, you'll want to use a deburring tool to shave off any excess material left behind. The next thing you'll want is Emery cloth. Emery cloth works by polishing the metal you rub it against. If you don't have any Emery cloth, you can use some sandpaper, but it's probably going to be weaker and leave you with a finish that you're not exactly happy with. The next thing you'll want is some cutting fluid, or coolant or oil, or really whatever you want to call it. The purpose of the cutting fluid is to ensure that your parts and tooling of the machine do not heat up to the point where it can damage either one. Using this will definitely increase the lifespan of your machine, and tools. Next, I've been holding off the star of the show for quite a while, the lathe. The lathe is vital in making the part and is absolutely necessary. The lathe also has several accessories or tools that you'll need to perform the operations required. The first thing you'll want is a general purpose diamond-shaped carbide cutter. You can use this for turning operations. Next, you'll want a facing tool to make an even starting surface. Next, you'll want a center drill, which is used as a guide for the pilot drill, and then an 8mm drill bit for the pilot drill. And this size can actually vary quite a bit, since it's only going to be used to make the pilot hole, not the final hole. And then for the final hole, you'll want an 18mm drill bit, and for me, it's 18mm because my finger size is slightly smaller than that, but you would use whatever drill bit size that works for your finger. And for the last thing for the whole operation is you need a countersink tool so that you can break the sharp edges on the outsides of your ring. Now, to add a design to the outside, you'll want a knurling tool. The knurling tool is not mandatory, but it really makes the design look a lot nicer. And finally, the last tool you'll need is a parting tool. The parting tool will help you cut off the excess stock material and get the ring to the right length that you want it to be. Okay, now that we've covered all the different tools and their purposes, and their alternatives, let's get to the fun part. The actual manufacturing process. The first and most important thing in any project that we must always start with is safety. Our 3 A's come into play here. The first thing we want to do is be aware of our surroundings. So inspect the machine shop for any unsafe machines or people. Some hazards to look out for are machines blocking exits or materials blocking exits, spilled water, frayed electrical cables, and machines without machine guards, too much dust, and so many more things. Just try and apply your common sense. The next A we need to consider is attitude. If you don't have the attitude to be safe, no matter how much you know about the potential risks in your surroundings, you won't be willing to do anything about it, and consequently, you'll get hurt. The final A is action. Now that you know about the potential dangers and have the attitude required to remedy them, that means you'll need to take the corrective action required, whether that means putting on PPE or informing your teacher about certain operational hazards in the shop. Specifically in terms of PPE, you'll want to be wearing safety goggles, and you should not be wearing any gloves, jewelry, loose-fitting shirts, or sweaters. Also, when you're working with chemicals like the cutting fluid, it is best to reference an MSDS sheet about the chemical to know the safety procedures in case of a spill or in case it enters your body. Now that you've made sure your environment is safe, let's get to actually making our part. I will first want to talk about setting the machine speeds to the correct speeds and feeds for each operation. Since we are machining aluminum, we can conservatively say that a cutting speed of 125 surface feet per minute will work. But what unit is surface feet per minute? Let's convert that to RPM. We can do this by using the formula 4 times the surface feet per minute divided by the diameter of the stock in inches. So we can fill this in and we'll get 4 times 125 divided by 1, because our stock material is roughly 1 inch in diameter. So that gives us around 500 RPM. We can use this speed for the facing, turning, and drilling operations. However, for the knurling operation, we'll want to use around 1/3 of that speed. So that's around 160 RPM. Okay, now that we know the speed for each operation, let's begin working with our part physically. The first thing you'll want to do is gather your stock material. We already mentioned the stock material is around 1 inch in diameter, but it needs to be at least 23 millimeters in diameter and at least 6 millimeters in length. This is so it can fit most size hand rings. You might need a larger stock if your finger is bigger than mine, so just make sure that you get some stock material that's bigger than your ring. First, apply your engineer's blue to one face of the stock material. Now, perform a facing operation on that face and take multiple passes if needed, until you can no longer see any of the blue. This will ensure that the surface is now perfectly flat. Place your center drill in the tailstock and use it to drill a small hole in the center of the part. Next, swap out the center drill for an 8mm drill bit. Then in the same fashion, drill a pilot hole using this drill bit. Now swap to your final drill bit. For me, it's the 18mm drill bit, and I'll drill a through hole. The last thing regarding the hole you'll need is to swap to your Countersink tool, and use it to make a small chamfer on your hole. That way you break any sharp edges that might cut you. Now, perform a turning operation to get the ring to the diameter you need. Additionally, for this operation, you'll want to use the live center to stabilize your part from both sides, since turning places a lot of tangential force on the part and the lathe. You will likely have to make several passes to get the correct amount of material off from the stock material, depending on how big your stock material is. These passes can be done with a rough turning tool, which can remove more material. However, for your final pass, you'll want to use a finishing turning tool, which only removes a little bit of material, but leaves a much nicer finish. Now that you have it at the right diameter, use your knurling tool to make that amazing pattern we saw earlier on the ring. Make sure you remember to set your speed to 1/3 of what we used before. Additionally, you'll want to use the live center once again to stabilize the part from both sides. Finally, with everything done, use the parting tool to cut the ring to the correct length. Now just recheck the dimensions, and if there's an error, see if you can put it back in the lathe and correct it. If not, you might need to grab a fresh piece of stock and restart. Now we're on the home stretch. Let's just put the final touches on the product. Use the deburring tool to remove any burrs from edges on the ring, and use the Emery cloth to assist with this if necessary. And once you're done that, you should have a really nice ring. And that's it. Now hopefully you have a really cool ring that you can wear around everywhere, and more importantly, hopefully you learned a thing or two. Thanks, that's all from me today.